Okay, so 7.5 is all about surface area and volume. You have to use the formulas exactly as they are on that formula sheet. Remember, on the SOL test, you can get the formula sheet on the computer, or you can ask for a paper copy. In the SOL booklet that you're working in right now, you can flip to the very front. There's also a formula sheet. Be sure to highlight the following information in the problem. Make sure that is it filling? That's volume. If you're filling something up, that's how much something will hold. Okay, for surface area, you need to think about covering that object, okay, or wrapping it. And that's something that you learned, 5th grade, 6th grade about surface area and volume. So question number 1, and of course my computer's being slow. All right, so question number 1 says, one way to determine the surface area of this cylinder. So surface area, that's all of the area of the surfaces of that shape. It's a cylinder. So A says we could add the areas of both the bases, so that's taking the area of the circle for the top, the circle of the bottom, and adding it to the rectangular area around the cylinder, okay? Or you could add the areas of both bases, multiply the area of the base by the height, multiply the rectangular area around the cylinder by pi. I know that when I was talking with some students earlier, they thought the answer was D because it said pi. Okay, just because something says pi does not mean that that's the answer. The answer is A. You have to add the area of the top, add the area of the bottom, and then you have to take that area of that rectangular piece around the cylinder. You've got to think about what that net looks like. So the answer for number 1 is A. So 2 says a container in the shape of a cube will be completely filled with sand. The length, or the container has an edge length of 8 inches. What is the exact number of cubic inches of sand needed to completely fill the container? So we're filling the container. Okay, so what formula is that? That's volume. And we know it's a it's a cube, which is basically a rectangular prism. So we know we're going to do volume equals length times the width times the height. Okay, well think about a cube. That means that each of those faces is in the shape of a square. Well, a square, okay, and it says that it has an edge length of 8. So this side is 8, this side is 8, this side is 8, this side is 8. Okay, so we need the length, the width, and the height. So my length would be 8, my width would be 8, my height would be 8. So that just means 8 times 8 times 8. Okay, you can use your calculator. Don't feel like you have to do all of this mental math. So 8 times 8 times 8 is going to be 512. All right, we're going to skip over to number 4 because I've got to scroll down. So we've actually done this one in class before. It says this table shows the dimensions of 4 rectangular prisms. So we have rectangular prism Q, R, S, and T, and they give us the length, the width, and the height of each one of those. It says which rectangular prism has the greatest volume. Okay, we know we're looking for volume, and it's a rectangular prism. So we know that we can just take the length, multiply it by the width, multiply it by the height. So now we just have to go through and find out which one of those has the greatest volume. So we're going to start with rectangular prism Q, and I'm going to do 8 times 4 times 5, because I'm multiplying the length times the width times the height, and that gives me 160. Okay, now I'm going to look at R. I've got 6 times 7 times 12. Remember, I did 6 times 7 times 12, and that gave me 504. So now I'm going to look at S, and I'm going to do 4 times 10 times 12, and that gives me 480. Now I'm going to do 2 times 13 times 5, and I get 130. So looking at those, well, obviously R has the greatest volume, so the answer would be B, rectangular prism R. All right, looking at number 3, the dimensions of 4 rectangular prisms are shown. Okay, so we know that they're rectangular prisms. Identify each of the prisms for which the maximum amount of sand that the prism can hold. All right, so we're looking at how much that the prisms can hold, so we know that that's volume, is 30 cubic inches. So we're basically trying to figure out which ones of these prisms has a volume of 30. So remember, volume equals length times width times height. You don't have to memorize that. You can look back at the formula sheet in the beginning of the book. So 15 times 2 is 30. 30 times 2 is going to be 60. So for this first rectangular prism, the volume is 60. So that's not going to work. That's too much. So the second one says 1, 3, and 3. So we know we're just multiplying 3 times 1, and that's going to be a volume of 9. Well, that's too little. We're looking for 30. Then the next one, 5, 3, and 2. So 5 times 3 is 15. 15 times 2 is 30. Okay, well, that's what I'm looking for, so that is an answer choice that I can select. Then I've got 6 times 5 is 30. 30 times 1 is 30. So that's another one that I can select because we're looking for 30 cubic inches that it can hold. All right, number 5 says that the diameter and height of a cylindrical container are shown. Keep in mind that this does say diameter, which means that the 16 is the diameter. The container is filled completely. When we're talking about filling something, we know that that's volume. Okay. With cheese sauce, which of these represents the total number of cubic inches of cheese in the container? All right, so we know we're looking at the volume formula. So flip over to the front of your booklet, and it says that the volume formula for a cylinder is pi r squared h. So now we need to figure out which one of those answer choices is going to match the pi r squared h. So now let's look back at our container. And it says, let's see, pi times r squared times h. Okay, well, we know that we can do volume equals pi. Well, what's our radius? I know that the problem says diameter. So the diameter is 16. Radius is from the center to the outer edge. And the radius is half of the diameter. So if the diameter is 16, I know my radius is 8. So I'm going to plug in 8 where my radius is. And then my height is 7. Okay, so my answer is obviously going to be A, because A shows pi times my radius squared times the height. I know a lot of you may have chosen B because, 16 squared, but 16 is the diameter, not the radius. So my answer is A. All right, number 6 says Trevor covered a cylindrical can with paper for a project. The can is 18 centimeters tall and has a 5 centimeter radius. Which is closest to the minimum amount of paper Trevor needed to cover the entire can? Okay, so we're covering the object, so we know that that's surface area. So flip to the front of your booklet. We're going to find the surface area formula for a cylinder. So we've got surface area equals 2 times pi times the radius squared plus 2 times pi times the radius times height. So now I'm just going to plug in the numbers that they gave me. My radius is 5, and we have to square that. I know that my radius is 5. The height is 18. Okay, so now I need to get an answer for the first part and the answer for the second part before I add. So I know I'm going to do, according to order of operations, I'm going to do the 5 squared first, and I know 5 squared is 25, not 10, because I can press the 5 button, and then I can press the X to the square button, or the X to the second power button, and that's going to give me 25. So 25 times 2 times 3.14 is 157. Now I'm going to do the second part, and that's 2 times 3.14 times 5 times 18. And that's going to give me 565.2. So now I have to add that with my 157, and I get 722.2. Okay, well, it says which is closest. So 722 centimeters squared is my answer for that one. Number 7 says Carl is covering the rectangular prism-shaped box with cloth. What is the minimum amount of cloth that Carl needs to cover the entire box? Okay, So we're talking about covering again, so we know that that's going to be surface area. So we've got to do 2 times length times width plus 2 times length times height plus 2 times width times height. And we've talked about that it really doesn't matter which one you want to use as length, width, and height because the commutative property of multiplication says we can multiply in any order that we want. I'm just going to go ahead and label 12 as my length. I'm going to label 2 as my height and 8 as my width. Okay, so now I'm just going to go through and plug in those numbers. And my length is 12, so I'm going to put 12 where the length is, 12 where the length is. Now I'm going to go through and put an 8 where the W is, and I'm going to put in 2 where the height is. Alright, so now I know I'm going to have to get 3 answers before I add. So I'm going to do 2 times 12 times 8, and I get 192. Then I'm going to do 2 times 12 times 2, and I get 48. Then I'm going to do 8 times 2 times 2, or 2 times 8 times 2, and I get 32. Now I can just add all 3 of those numbers together, so 192 plus 48 plus 32 gives me 272 square inches. All right, I'm going to flip up to number 9, so I don't have to scroll down. So it says a rectangular prism has a height of 3 inches and a volume of 27 cubic inches. So we already know that the volume is 27. The height of this prism is changed to 6 inches. So my original height was 3, my new height is 6, and the other dimensions stay the same. Well, I know that to go from a height of 3 to a height of 6, I'm multiplying that 3 by 2, which means I can just take my volume and multiply it by 2, and I get 54. Because whatever we're doing to one of those attributes, the same thing is going to happen to the volume. So if I'm multiplying my height of 3 by 2 to get a new height of 6, I'm just going to multiply my original volume by 2 to get a new volume of 54. Number 10 says rectangular prism A is shown. Rectangular prism B has the same height and the width as rectangular prism A, but its length is now 8. So this is prism A. Prism B is going to have the same height and the same width, but it's going to have a new length. So my new height is 5, or my old height is 5, my width is 3, my new length is 8. So what's happening with my length here and my length here? I'm multiplying the 4 by 2 to get 8. So what's going to happen to, or what's my new volume? I'm going to multiply it by 2. It's going to be twice the volume of prism A. All right, number 8 says the length of rectangular prism A is shown. Okay, so there's prism A. The length of this prism is multiplied by a scale factor of 1/2 to create rectangular prism B. So what's going to happen to the volume of rectangular prism B? So we're going to cut, or basically multiply 6 by 1/2, which is going to give us 3 inches. So then we're going to have to do the same thing to the volume, multiply it by 1/2. That's it. Whatever we're doing to the attribute, the same thing happens to the volume. So number 11 says a company has produced a cereal box with the following dimensions and needs to reduce the surface area due to cost of production. Which situation will create the least surface area? So we're trying to make it the smallest surface area. So what's going to happen to, let's see, we can multiply the length of a scale factor of 1/3, multiply the width by a scale factor of 1/3, multiply the height, or multiply the length by 1/2. Well, the height is the largest. So if we can minimize that height, then it's also going to minimize the surface area. So if we take that height and cut it in half, that's going to give us the smallest surface area.